Hello everyone, welcome to my channel Engineering Studies. In the previous lecture, we have seen a brief introduction of a digital system. So in today's video, we are going to start with a digital number system topic. So what is a number system? Number system is a way of counting, and also it is very useful in digital technology. So let us consider this example. So from this arrangement, we are going to see what is the significance of each alphabet here. So the example is PQRS.TUVW to the base R. So here R is nothing but a radix or a base. And this decimal point is radix point or base point. Okay, so how we are going to read this example? To the left of the radix point, we have this term called S. So we are going to define a place value and its face value. So place value will be R raised to 0. Why R? Because R is its radix or base. So here the place value will be R raised to 0. And also face value will be S. When we will go to the left of the S, the place value of R will be R raised to 1 and face value will be R. So similarly for Q, the place value will be R raised to 2 and face value will be Q. And for P, the place value will be 3, that is R raised to 3 and face value will be P. On the other hand, to the right side of the radix point, the R index will change. So for the T, the place value will be R raised to -1 now and face value will be T. For U, it will be R raised to -2 and face value will be U. For V, place value will be R raised to -3 and face value will be V. For W, place value will be R raised to -4 and face value will be W. So here the same thing is written, radix R represents a number in a number system. So let us see some examples and understand it in more details. Now we have this system, that is 25 plus 18 equal to 41. So here we need to find out the base of the given system. Okay, so how we are going to find it? Let us see. Now we will consider 25 number first. So we know that the place value of 5 is R raised to 0 and place value of 2 is R raised to 1. Therefore, write it down. So 2 into R raised to 1 plus 5 into R raised to 0. Similarly, for this number 18, we are going to write its place value. So 1 into R raised to 1 plus 8 into R raised to 0 equal to 4 into R raised to 1 plus 1 into R raised to 0. So what is R raised to 1 is R. Therefore 2R plus 5 into R raised to 0. The value of R raised to 0 is nothing but 1. Therefore 5 into 1 will be 5 plus 1 into R raised to 1. R raised to 1 is R. So 1R plus 8 into R raised to 0. R raised to 0 is 1. Therefore 8 equal to 4R plus 1. When we will solve this, we will get R is equal to 12. Now let us go further and understand this second example. So the system is root 42 equal to 6. Same thing, we need to find the base of the system here. Now under root, we are going to write the place value of this number 42. So let us start first with the number 4. So 4 into R raised to 1 plus 2 into R raised to 0 equal to 6 into R raised to 0. Therefore, under root of 4R plus 2 equal to 6. Now squaring both the sides, we will get 4R plus 2 equal to 36. So by solving this, we got R is equal to 8.5. So this is the answer for this example. But always keep in mind that mostly the base of the system is always a whole number. So here we got a fractional part. Now the next example. In a number system, roots of x square minus 11x plus 22 equal to 0 are 3, 6. So we have to find the base. So this is the given system and roots are given for it. That is 3, 6. Now as we will observe this, this is a equation. So we will compare this equation with the standard equation. So we know that the standard equation is ax square plus bx plus c equal to 0. So for this standard equation, the product of roots are given as c upon a and the sum of roots are given as minus b upon a. So let us compare the given equation with the standard equation. So we will get the value for a, b and c. So a is 1, b is minus 11 and c is 22. So let us pick up any one of the mathematical expression. So let us pick up product of roots. So product of roots means we are gonna perform the product of these two numbers, that is 3 and 6. So let us do it. Therefore 3 to the base r, 6 to the base r will be equal to c upon a. C is nothing but 22 and a is 1. Therefore 22 to the base r divided by 1 to the base r. So we will write place value for these two numbers. So the place value for 3 is r raised to 0 and place value for the 6 is r raised to 0. So 3 into r raised to 0 into 6 into r raised to 0, because we are going to perform a product of these two roots. Now equal to, same thing, we are going to multiply 2 into r raised to 1 plus 2 into r raised to 0 upon divided by 1 into r raised to 0. So we will get 3 into 6, that is 18, and 2 into r is 2r plus 2 divided by 1. Therefore on solving this, we will get the value for r as 8. Now I hope you understood this example. Now we will go further. So in the next example, we have to evaluate this equation. So let us read this. The system is 1.3 to the base 4 plus 2.4 to the base 4 equal to dash to the base 4. Now how we are going to proceed? First of all, let us write this in the addition form. So 1.3 plus 2.4. Now as we know, the base is 4, but when we will perform the addition of this system, we will get the result in a decimal form. So, but we don't want it in a decimal form. We want it in a 4 base form. So what we are going to do, let us see. Now, first we will do a normal addition. That is 4 plus 3 is nothing but 7. So I have written here 7. So as we need a 4 base system, so divide this number with 4. So 4 ones are 4, remainder will be 3. So the 7 to the base 10 is now converted into 13 to the base 4. Similarly, we are going to write 13 number here. 1 is carried over. Now 2 plus 1 is 3 and 3 plus 1 is 4. Again, we are going to divide it by 4. So 4 ones are 4, remainder is 0. So write this 10 number in the form of 4 base system. So 4 to the base 10 equal to 10 to the base 4. Now we got the answer of this system as 1.3 to the base 4 plus 2.4 to the base 4 equal to 10.3 to the base 4. So that was all for the base system. Now let us go further and read some number systems. So these are some different kinds of number systems. That is binary number system, decimal number system, octal number system, and hexadecimal number system. So let us see what is binary number system. So the base of binary number system is 2 and the numbers included in this system is 0 and 1 only. So these numbers are known as bits. So whenever 4 bits will come together, we will call it as 1 nibble, and whenever 8 bits will come together, we will call it as 1 byte. Now let us see what is decimal number system. The base of the decimal number system is always 10 and the numbers included are 0, 1, 2, 3 to 9. That is 0 to 9. Now let us understand these two number systems in more detail by considering some examples. Now let us first start with the conversion of binary to decimal. So our first example is we need to find a decimal number representation of this binary number. So we can see this is a fractional number. Okay. So how we are going to proceed? We will first start with the left portion of the radix point. So we can see here, this is a radix point and this is radix 2, that is base 2. Okay. So we know that to the left of the radix point, we are going to start with the place value r is to 0. And similarly, the value of index of r will increase further. So let us start. First, we will take this 1. So 1 into 2 raised to 5 because r is here 2 now. So 1 into 2 raised to 5 plus 0 into 2 raised to 4 plus 1 into 2 raised to 3 plus 1 into 2 raised to 2 plus 1 into 2 raised to 1 plus 0 into 2 raised to 0. Now towards the rightmost portion, we are going to start with the r raised to minus 1, right? So r is 2 here again. So plus 1 into 2 raised to minus 1 plus 0 into 2 raised to minus 2 plus 1 into 2 raised to minus 3 plus 0 into 2 raised to minus 4 plus 1 into 2 raised to minus 5. Now we are going to solve it. We know that 1 into 2 raised to 5 is nothing but 32 and 0 into 2 raised to 4 is 0. Here it is 8 plus 4 plus 2 plus 0 plus 2 raised to minus 2 is nothing but 1 by 2 plus 1 into 2 raised to minus 3 is 1 by 8. 1 into 2 raised to minus 1 is 1 by 2 and 0 into 2 raised to minus 2 is 0. 1 into 2 raised to minus 3 is 1 by 8 plus 0 plus 1 into 2 raised to minus 5 is 1 by 32. So when we will solve this addition, we will get 46.65625 to the base 10. So what we have done here, we have converted this binary number into its decimal equivalent, which is 46.65625 to the base 10. Now we will go further and learn how to convert a decimal number into a binary number. So let us see one example for it. So what we have to do here, we need to convert 15 to the base 10 into its equivalent binary number. So the number is 15 and we need to convert it into a binary number. Binary number means r is equal to 2. So what we have to do, we have to divide this number 15 by 2. So 2 sevens are 14, remainder 1. 2 threes are 6, remainder 1. 2 ones are 2, remainder 1. 2 zeros are 1, remainder 1. So how we are going to read it, how we are going to write it, in fact, this binary number from MSB to LSB. So the highermost number is called as MSB and the lowermost number is called as LSB. So the 15 to the base 10 will be written as 4 times 1 to the base 2. So here this is LSB and this is LSB and this is MSB. Okay. This is LSB and this is MSB. Now we are going to consider this second question. So what we have to do, we have to convert this fractional part, that is 0.65625 to the base 10 into its equivalent binary number. Now the procedure for this fractional number will be a bit different from the above procedure. So let us start. So we need to write down this number here and we need to multiply it by 2 because we want its binary equivalent, right? So let us do. So we know that 5 2s is 10, carry over 1. 2 2s are 4 plus 1 is 5. 6 2s are 12, carry over 1. 5 2s are 10, carry over 1. 5 2s are 10 plus 1 is 11, carry over 1. 6 2s are 12 plus 1 is 13, carry over 1. So we got 1.31250. So now we need to just extract this number to the left of the radix point, that is 1, and consider this remaining part here for the further calculation. So the number is now 0.31250 multiplied by 2. Now 2 zeros are 0, 2 5s are 10, carry over 1, 2 2s are 4 plus 1 is 5, 2 1s are 2, 3 to the 6.0. Now to the left of the radix point is 0. So extract this 0 and consider the remaining part for the next calculation. Now the number is 0.62500 multiplied by 2. Now 2 zeros are 0, 2 zeros are 0, 5 to the 10, carry over 1, 2 to the 4, plus 1 is 5, 6 to the 12, carry over 1. Now extract this one. Take the remaining part for further calculation. Multiply it by 2. We will get 0.5 4 times 0. Extract this 0. Consider the remaining part for the further calculation. Multiply it by 2 again. So at the last we got 1.5 times 0. Extract this one. So remainder is 0. So discard. Now the answer for 0.65625 to the base 10 is 0.10101. So these are the numbers which were extracted from the left portion of the radix point. Okay. So that's it for a conversion of decimal to binary. So this is all for today. In the next video, we are going to learn 2 more type of number system, that is octal number system and hexadecimal number system. I hope today you have understood everything. So let us finish up this video. Please like, share, comment and subscribe. Thank you.